What would it mean for a universe if everything that turns suddenly didn't? And why, in a cosmos born from silence and heat, do atoms, planets, stars, and entire galaxies inherit the same ancient habit of spinning in one shared direction? If this quiet journey into the turning of the universe brings you a moment of calm, a gentle like, or a soft tap on subscribe, truly helps this small corner of the cosmos stay alight. As you settle into the stillness around you, you might notice how motion can feel distant, almost unreal, as if the world has paused for the night. Yet even now, the atoms inside your body are spinning with angular momenta set billions of years ago. The Earth beneath you is rotating at more than 1,000 kilometers per hour at the equator, carrying you smoothly through the dark. The Sun is spinning. The Milky Way is spinning. And on scales so vast they escape ordinary imagination, the cosmic web itself shows hints of subtle-handedness, as though the universe remembers the direction of its own birth. This great turning is not chaotic or random. It is an inheritance. It begins with the earliest moments after the Big Bang, when the universe was not yet a place with stars or galaxies, but a soup of quantum fluctuations, each one a tiny seed of density, etched with its own slight imbalance. These fluctuations, studied through the cosmic microwave background by missions like Planck and WMAP, show patterns of temperature anisotropy only a few tens of microkelvin deep. Yet those faint imprints became the scaffolding for everything that would later spin. When matter began to gather, tiny irregularities grew under the pull of gravity. But gravity alone does not create rotation. It merely brings matter closer. The turning begins because no accumulation of matter is ever perfectly symmetrical. A cloud of gas will always have a slight unevenness, a small offset in its internal motions. As it collapses, conservation of angular momentum, one of the quietest and most reliable principles in physics, amplifies that tiny asymmetry into a sweeping rotation. You can imagine holding your arms out and pulling them in during a gentle spin. The speed increases not because something pushes you, but because your rotation must conserve itself. The universe does this on scales 1,000,000 trillion times larger, letting every cloud that collapses into a star, every coalescing disk that becomes a galaxy, turn faster and faster as it contracts. When the first stars ignited, they did so already wrapped in spin. When the Milky Way grew, it did so as a disk rotating around a dark matter halo whose own angular momentum emerged from the same ancient imperfections. And even when black holes formed, their spin, measured today by observatories like NICER and inferred from X-ray spectra of accretion disks, was the distilled memory of the motions of long-dead stars. In the quiet of your room, where the night folds around you, it may feel as if all this belongs to some unreachable distance, but the spin of the universe is not far from you at all. Every electron in your body carries intrinsic spin, a quantum property more fundamental than a classical rotation, described by the mathematics of SU2 symmetry. It is as if matter itself contains a whisper of cosmic directionality, so integral to its identity that it defines the structure of atoms, the shapes of molecules, even the chemistry of your breath. Without spin, the Pauli exclusion principle would collapse, electrons would fall into identical states, and atoms would lose their scaffolding of shells. Matter would flatten into something dense and featureless. Your world, as you know it, would be impossible. And if galaxies stopped turning, the consequences would be just as profound. Their spiral arms, shaped by density waves and orbital resonance, would lose their sweeping structure. The centrifugal support that holds stars in graceful orbit would vanish. Gravity would begin to pull everything inward, compressing the disk toward the center. Over time, the galaxy would collapse into a more compact spheroidal form, its elegant spirals erased. But such a stopping cannot happen on its own. Angular momentum does not simply disappear. It can be transferred through tidal torques, through gravitational interactions, through mergers in the darkness between clusters, but it cannot be destroyed. Even the collisions of galaxies, like the future merger between the Milky Way and Andromeda, do not eliminate spin. They rearrange it. They blend it. They cast it into new structures, letting angular momentum reshape itself into the remnant elliptical form. The universe, by its nature, keeps turning. If the universe had been born without the faint irregularities generated during inflation, nothing would spin at all. Matter would fall straight inward. Stars would form as static spheres. Planets would not trace orbits but plunge directly into their suns. Without rotation, no magnetic fields would arise, for magnetic dynamos rely on motion, on differential rotation, on swirling currents of conducting matter. A still universe would be a silent one, without auroras, without shielding from stellar winds. Life would have little refuge. But our universe was never destined for stillness. The inflationary period, with its quantum fluctuations stretched across cosmic scales by exponential expansion, ensured that slight twists and offsets would become the seeds not only of galaxies, but of their spins. You can think of those earliest fluctuations as soft ripples on a vast ocean. As the ocean expands, the ripples stretch, yet their curvature remains. When gravity begins to sculpt the early universe, it does so using these faint patterns as blueprints. And so, across billions of light years, the cosmic web forms: filaments, nodes, and voids. Galaxies align along these filaments, drawing angular momentum from the tidal forces around them. Current surveys, like those from the Sloan Digital Sky Survey and the Vera C. Rubin Observatory, continue to hint that spins may reflect deeper symmetries in the distribution of matter, perhaps even pointing toward a subtle universal handedness. Whether this asymmetry is real or an artifact of incomplete sky coverage remains an open question. But the possibility is quietly profound. It would mean the universe itself carries a preferred direction, a memory of something imprinted before even the first light appeared. As you listen, notice how the notion of preferred direction feels both intimate and immense. You, lying here in stillness, are carried by a planet that was shaped by rotation. Its equatorial bulge, its climates, its daily cycle of light and darkness, you experience these because Earth spins. Its rotation comes from the angular momentum of the gas and dust that formed the solar system, itself inherited from the larger cloud that birthed the sun. That cloud gained momentum from the motions of material in the Milky Way, and the Milky Way gained momentum from its formation out of the early density field. You are, in a very real sense, a continuation of ancient cosmic turning, written into the structure of your atoms, the path of your orbit, and the slow drift of your star through the galactic disk. If all motion could be paused in an instant, if every rotation at every scale could halt, the universe would become unrecognizable. Planets would collapse inward. Stars would evolve differently. The stability provided by angular momentum would dissolve. Yet, such freezing is impossible under the laws that govern reality. Angular momentum, conserved with perfect steadiness, is one of the universe's most faithful commitments, a promise that turning will continue as long as space-time exists. Even when two neutron stars merge, releasing gravitational waves detected by LIGO and Virgo, the remnant object often spins even faster, compacting angular momentum into a smaller space, carrying forward the memory of their individual rotations. Even when supermassive black holes collide, their spins and orbital angular momenta reshape the space-time around them, radiating energy outward while preserving the total rotation of the system. There is a quiet comfort in this cosmic persistence, a sense that the universe does not forget its early motions. As you breathe gently, you can imagine the faint rotation of the Earth beneath you as part of a chain stretching back to the first trembling fluctuations in the early universe. Even the direction of Earth's rotation, prograde relative to most planets, is a reflection of angular momentum inherited from the solar nebula. Venus, with its retrograde spin, is a reminder that collisions and tidal interactions can rewrite local histories, yet even this reversal preserves magnitude and directionality in a broader sense. Angular momentum is never lost, only redistributed. The cosmos is a dance of exchange. In this moment, while your body is still and the night folds quietly around you, imagine the vast turning of the Milky Way. Our galaxy spins at roughly 200 kilometers per second at the Sun's position, completing a rotation every 230 million years. The Sun has made only about 20 orbits since it formed. As it moves, it carries you with it, gently tracing a path through spiral arms, past regions of star formation bright with nebulae, past ancient globular clusters that orbit like distant lanterns at the galactic edge. All of this motion is so smooth, so immense, that you feel none of it. Your perception of stillness is not an illusion, but a perspective shaped by scale. Large motions become quiet when you move with them. Even atoms carry this quietness. Their electrons do not orbit like planets, yet their angular momentum, intrinsic and orbital combined, defines the architecture of the periodic table. Spectroscopy, one of the oldest tools in astronomy, relies on transitions between quantized angular momentum states, allowing us to study stars light years away. The same quantum rules that give shape to atoms allow us to read the chemical compositions of distant galaxies from their light. Spin, in this sense, is a universal language. It speaks through the patterns of absorption lines, through the broadening of spectra caused by rotation, through the synchrotron radiation emitted by charged particles spiraling in magnetic fields. Even the most distant radio galaxies whisper their spin through the polarization of their jets, observed by telescopes from the Very Large Array to ALMA. Yet beneath all this turning lies a deeper question. Why did the early universe have imperfections at all? Without them, angular momentum would have no foothold. Inflationary theory suggests that quantum fluctuations, normally confined to subatomic scales, were stretched to astronomical sizes by the rapid expansion of spacetime. The fluctuations became seeds for galaxies, clusters, and filaments. They also became seeds for rotation. If inflation had been perfectly smooth, an unrealistically ideal scenario, no structure would form. The universe would expand in featureless simplicity. But quantum mechanics, with its inherent uncertainty, ensured that perfect symmetry could never hold. Those fluctuations, once microscopic, became the architects of cosmic motion. As you rest into this story, notice how the universe's great rotations seem both inevitable and delicate. They arise from laws that have no agenda, from symmetries and their breakings, from the tug of gravity, from the persistence of angular momentum. Yet they create spirals of stars, swirling storms on Jupiter, magnetic fields that shield planets, atomic structures that support life. Everything you know emerges from turning. Even time, as measured by the rotation of Earth, carries the imprint of angular momentum. Your days, your nights, your memories of light and darkness, all are shaped by a planet that spins because a cloud of gas once contracted and preserved its rotation with quiet fidelity. And if you imagine, for a moment, a cosmos where that first cloud had been perfectly still, you can see how fragile our reality is. A small asymmetry, amplified across billions of years, becomes the pattern of the night sky. A slight twist becomes the Milky Way. A faint rotation becomes the cradle of planets. Life arises in a universe where stillness is impossible, where motion is woven into the fabric of existence. And as you breathe, you can sense that woven motion in the calm inside your own body. The quiet rhythm of your pulse echoing the ancient rhythm of the spinning stars. But what gives these rotations their stability across billions of years? And why does the universe protect angular momentum so faithfully when so many other quantities can dissolve into heat or radiation? The answer lies in symmetry, one of the quiet governing principles beneath every movement in nature. According to Noether's theorem, whenever a physical system is symmetric under rotation, whenever the laws of physics do not change as you turn around, angular momentum is conserved. This connection is deep, almost monastic in its simplicity. The survival of spin is not a coincidence, but a reflection of the universe's unchanging rules. The cosmos does not care where you face, and because of that indifference, rotation becomes sacred. It cannot vanish. It can only be transferred from one form to another, shared between stars and planets, woven through collisions and tides, written into the gentle curvature of space-time. Imagine drifting through the early solar nebula long before Earth formed. Gas and dust swirled through a disk shaped by angular momentum inherited from a cloud that inherited its own spin from the broader galactic environment. Tiny grains collided and stuck together, building planetesimals. These planetesimals clumped into protoplanets, and as they grew, they carried the rotation of the disk into their bodies. Earth formed as a turning world because the disk itself turned. And the disk turned because the gas cloud collapsed with a slight asymmetry. That asymmetry came from galactic tides and from the primordial motions carved into matter during the universe's first few 100 million years. Layer by layer, motion was handed down, like an ancient story whispered through time. When the moon formed, likely from a colossal impact with a Mars-sized body, the collision redistributed angular momentum between Earth and its orbiting debris. The Earth-Moon system became a paired movement, gradually exchanging rotation through tidal forces. Over billions of years, Earth's rotation slowed while the Moon drifted outward. Today, the Moon shows only one face to us because tidal locking has synchronized its rotation to its orbital period. This quiet interaction between two turning bodies reflects the same principle that shapes galaxies and clusters. Motion moves between objects, but never disappears. Even the tides you sense on Earth's coasts are echoes of ancient angular momentum exchange, a soft tug-of-war set in motion 4.5 billion years ago. When you lift your mind into the scale of galaxies, the same logic unfolds in grander patterns. The Milky Way spins because the tidal gravitational field of the early universe imparted a torque on the forming halo. These torques, predicted by tidal torque theory, arise from misalignments between a protohalo's inertia tensor and the surrounding density field. They give newborn galaxies their initial spin. Over time, mergers and accretion reshape this angular momentum, yet the overall rotation persists. In spiral galaxies, gas clouds fall toward the center but conserve angular momentum, flattening into a disk. The inner regions spin faster than the outer ones, creating a rotation curve that puzzled astronomers until dark matter was invoked to explain the missing mass. Dark matter halos, invisible but massive, cradle galactic rotation, preventing stars from flying apart. Consider this for a moment. Even the invisible matter we cannot touch or see participates in the grand turning. Simulations like Illustrious and Eagle show that dark matter filaments twist slightly as they grow, inducing spin on the galaxies locked within them. The gas follows the dark matter, cooling into a rotating disk. Stars follow the gas. Planets follow the stars. You follow the planet. This chain of motion links your quiet breathing tonight to the cosmic web stretching across billions of light years. If everything in the universe spins the same way, or even tends toward a shared orientation, we must ask where this preference originates. Some surveys have suggested that spiral galaxies show a handedness asymmetry, that one spin direction dominates in certain regions of the sky. While this remains an ongoing investigation, if confirmed, it could hint that the early universe contained a slight global twist, a cosmic vorticity imprinted during inflation. Such a preferred direction would not violate the laws of physics, but would reveal that symmetry was broken at the birth of space-time itself. Quantum fluctuations expanded to cosmic scales could have carried a tiny rotational bias, one so faint that only vast statistical surveys across billions of galaxies can detect it. Picture this subtle orientation as a quiet breeze in an otherwise still forest. You may not notice it by examining a single tree, or even a handful, but when you look across the entire woodland, you see the branches leaning ever so slightly, shaped by something gentle yet persistent. The universe may carry such a leaning, not a force that pushes, but an early imprint that guides the direction of structure formation, allowing spin to settle into patterns. Even on the smallest scales, rotation is essential. The spin of electrons, measured through the Stern-Gerlach experiment, showed that particles deflect in discrete directions under magnetic fields, revealing their quantum angular momentum. The concept of intrinsic spin helped explain the structure of atoms and the behavior of magnetic materials. Without spin, the entire periodic table would collapse into monotony. The diversity of matter arises from the ways electrons fill orbitals defined by their angular momenta. The colors of stars, the chemistry of oceans, the folding of proteins, all emerge from quantum rotation. Pause here for a moment. Consider how improbable it is that quantum spin, galactic spin, and planetary spin all arise from the same underlying principle, shaped by the same conservation law, guided by the same symmetry. From the smallest particles to the largest galaxies, turning becomes a universal signature, a quiet affirmation that the cosmos is not a place of static perfection, but of motion woven deeply into its fabric. Now imagine what it would be like if angular momentum could truly disappear. Without rotation, stars would collapse more easily, becoming denser objects sooner. Neutron stars, some of which spin hundreds of times per second, would form differently, perhaps without the magnetic fields that produce the pulsar signals we observe across the sky. Black holes, many of which are rapidly rotating Kerr black holes, would lose their ergospheres and the possibility of extracting energy through the Penrose process. The cosmic dance of accretion disks around black holes, glowing in X-rays and shaping the growth of galaxies, would vanish into a simpler, quieter process. Motion would have no history to preserve. But in our universe, rotation shapes nearly everything, even gas in interstellar clouds collapsing under gravity, fragments because of angular momentum, forming multiple stars instead of one. Many binary star systems exist because a single rotating cloud could not collapse smoothly, splitting instead into two stars orbiting a common center. Entire solar systems, like ours, are built from the flat, rotating disks that emerge naturally from conserved momentum. Without spin, planetary systems would be rare. Life, sheltered on worlds with magnetic fields and day-night cycles, might be exceedingly uncommon. The cosmic microwave background itself contains information about early angular momentum fluctuations, subtle polarization patterns, mapped by missions like Planck and future experiments like CMB-S4, may one day reveal whether the early universe held a trace of vorticity, a primordial swirling embedded in space-time before matter existed. If such vorticity is discovered, it would reshape our understanding of how spin pervades the cosmos, offering a deeper glimpse into the first fractions of a second after the Big Bang. As you drift deeper into this quiet exploration, notice how rotation becomes a metaphor for continuity. Everything turns, yet nothing returns to its exact starting point. Motion creates shape, structure, stability. Even the rhythm of your breath, gentle and unhurried, carries its own cycle. In every rising and falling, there is a kind of turning, a returning without repeating, a spiral through time. The galaxies, turning above you, unseen through the ceiling and the atmosphere and the night, are not spinning wildly but steadily, like ancient wheels forged from gravity and memory. Their spiral arms are not frozen structures, but patterns generated by density waves, where stars move in and out like travelers through gentle traffic. These patterns persist because rotation stabilizes them, preventing collapse. And beneath them, in the vast spaces between clusters, dark matter halos spin with even slower, quieter motion. Their rotation is not something you can see, but something revealed by simulations and inferred through gravitational lensing. They cradle galaxies the way a cupped hand might cradle a firefly, firm enough to hold, gentle enough not to crush. And as you sink more deeply into this unfolding night, let yourself imagine the entire cosmic web turning ever so subtly, its filaments twisting like threads in a vast tapestry woven across billions of light years. Though this rotation is not something you could watch with your eyes, supercomputer simulations reveal that the filaments themselves gain angular momentum as clusters merge and dark matter streams along gravitational channels. The motions are faint, nearly imperceptible on human timescales, yet they shape the alignment of galaxies born within them. A subtle twist becomes a shared orientation. A shared orientation becomes a pattern. A pattern becomes the quiet answer to why so many galaxies spin the same way. But underneath this lies an even older story, one wrapped inside the physics of the early universe. During inflation, space-time expanded faster than light could travel, smoothing out most irregularities while amplifying quantum fluctuations into cosmic seeds. But inflation did not erase every asymmetry. If a tiny rotational mode existed, even one unimaginably small, inflation would stretch it across the entire observable universe. That faint, ancient twist could then influence the direction in which large-scale structures formed, giving rise to correlations in galaxy spin-handedness. This possibility remains speculative, but it falls within the realm of theories that cosmologists explore with careful precision, using data from surveys such as LSST, Euclid, and the Dark Energy Survey. Feel how quiet that idea is. A whisper of rotation embedded not in matter, but in spacetime itself. A prelude to motion woven into the fabric of reality before atoms existed. It is a concept so delicate that only the collective light of billions of galaxies can reveal its presence. And yet, if true, it would mean that the reason everything turns in roughly the same direction is not a coincidence of local physics, but a birthmark of the universe. Now drift to a smaller scale, where the turning of planets becomes a story of inheritance. Jupiter spins once every 10 hours, flattening its shape and fueling storms that last centuries. Saturn, with its muted hues and rings composed of ice and dust, rotates almost as quickly. Their rapid spins come from the collapse of the gaseous regions that formed them, shaped by the same angular momentum that governed the solar nebula. As these giants rotate, they generate magnetic fields so large they sculpt their surrounding space, carving magnetospheres that extend millions of kilometers. Their moons orbit within these sculpted regions, tracing paths shaped by spin-driven magnetism. Earth's own magnetic field, born from the rotation of its molten outer core, protects every living creature from solar winds and cosmic radiation. Without the dynamo effect powered by rotation, Earth would be as vulnerable as Mars, whose weak magnetic field offers little protection. Life depends on this ancient turning, a quiet shield born from motion deep within the planet. Even the auroras dancing over Earth's poles are luminous reminders of this rotation-driven protection. When you look at the sky, even if only in your memory, the stars appear fixed, but they are not. Polaris will not always mark the north. Earth's axis precesses like a slow, regal top, completing one cycle every 26,000 years. This motion, caused by the gravitational pull of the sun and moon, subtly shifts the orientation of the sky across millennia. Civilizations past and future see different heavens, all because the Earth turns not only on its axis but around a shifting axis. Rotation, again, shaping perception. On even larger scales, clusters of galaxies rotate as well, though their motions are slower and harder to detect. Observations of galaxy clusters like Abell 2107 suggest coherent rotational motion spanning millions of light-years. These immense structures, containing thousands of galaxies, behave like colossal wheels turning through the dark. Guided by the gravitational interplay of visible matter, dark matter, and the shape of the surrounding cosmic web. The rotation of clusters echoes the same ancient processes: collapse, asymmetry, conservation, merely writ larger across the universe. As you feel the softness around you, consider how rotation influences even the expansion of the universe. While the expansion itself is uniform on large scales, small rotational modes can interact with density fluctuations, shaping the growth of structure. The cosmic microwave background contains polarization patterns that may encode these rotational influences. Experiments like SPT pole and ACT pole search for B-mode polarization. a subtle twist in the alignment of light waves that could hint at early universe rotational fields. These patterns are faint, quieter than the quietest whisper, yet they hold clues to why the universe evolved as it did. Even black holes, those regions where space-time curves so extremely that nothing can escape, carry rotation as a defining feature. A rotating black hole, described by the Kerr metric, drags space-time around with it, producing frame dragging strong enough to twist magnetic fields and accelerate jets that can stretch hundreds of thousands of light years. These jets, observed by telescopes such as Hubble and Chandra, are driven by rotation-transformed energy, a reminder that even in the darkest places, spin gives shape to light. The spin of a black hole reveals the history of everything it has consumed. If a black hole grew primarily through the collapse of a massive star, it inherits the star's angular momentum. If it grew by devouring gas swirling in an accretion disk, its spin aligns with the disk. If it grew through mergers, its spin becomes a memory of cosmic collisions, encoded in the ripples of spacetime detected by LIGO and Virgo. In this way, every black hole becomes an archivist of cosmic motion. Now drift further inward, to the scale of individual atoms. Atomic nuclei also carry spin, a quantum property determined by the angular momenta of protons and neutrons. Nuclear spin affects hyperfine transitions that define some of the most precise clocks ever built. The SI second itself is defined using the hyperfine transition of cesium atoms, which depends on nuclear spin alignment. Your experience of time, your sense of past, present, and the gentle approach of sleep is measured using a process rooted in quantum rotation. Even the stability of matter depends on the spin statistics theorem. Fermions, such as electrons and quarks, have half-integer spin and obey the Pauli exclusion principle, giving matter its structure and preventing collapse. Bosons, like photons and gluons, have integer spin and can occupy the same state, allowing phenomena like lasers and superconductivity to arise. The contrast between these two classes of particles creates the entire diversity of the material world. Spin, at its core, is not merely a property, but a fundamental organizing principle of nature. As the universe ages, spin continues to guide its evolution. Angular momentum influences galaxy mergers, star formation rates, and the shape of cosmic structures. When two galaxies collide, their stars may pass through each other without direct contact, yet the gas clouds collide and compress, triggering new star formation. The angular momentum of the merging system dictates whether the resulting galaxy becomes a rotating spiral or a more spheroidal elliptical. Over trillions of years, as star formation dwindles and galaxies merge into larger structures, rotation may become slower, more diffused, but never fully lost. Now, return to the question of what would happen if everything stopped spinning. Imagine, just for a moment, a universe where angular momentum could be drained away. Planets would fall into their stars. Stars would collapse inward, flaring briefly before shrinking into compact remnants. Galaxies would crumple into dense cores. Black holes would lose their frame-dragging power. Magnetic fields would vanish. Clocks would fail. Atoms themselves would lose their structure. The universe would flatten into a silent geometry, lacking the cycles and rhythms that define both cosmic evolution and human experience. But such a universe is not ours. Here, symmetry preserves motion. Conservation protects the turning of galaxies, the spin of electrons, the wobble of planets, the dance of clusters. Everything moves because the universe allows it, because its laws encourage continuity over stillness, because time and rotation are intertwined in the silent mathematics beneath all creation. And now, as you float gently in this sea of thought, you can feel how even your own sense of stillness participates in a larger flow. You are turning with the Earth. You are orbiting the Sun. You are circling the center of the Milky Way. You are drifting through the cosmic web. You are shaped by quantum spin, shielded by planetary spin, carried by galactic spin, and perhaps whispered into existence by a primordial twist of space-time. And as your awareness settles even more deeply into this unfolding universe of turning, imagine a single strand of light leaving a distant quasar billions of years ago. That light has crossed expanding space, has passed near rotating galaxies whose gravity bent its path, has skimmed the edges of clusters whose collective spin shifted its frequency through gravitational lensing. By the time that photon finally reaches a telescope on Earth, its journey carries the imprint of countless rotations, woven into the slight distortions of its path. Even the polarization of that light may twist as it travels through magnetized intergalactic plasma, shaped by rotational fields born from ancient cosmic motions. A single ray of light becomes an archive of turning. When astronomers map the large-scale structure of the universe, they do so by collecting these accumulated hints: galaxy orientations, spin directions, peculiar velocities, and comparing them to simulations that recreate cosmic evolution from the first moments after recombination. These simulations often begin as almost featureless clouds of dark matter and gas, seeded with fluctuations measured by missions like Planck. As gravity amplifies the fluctuations, filaments form, halos grow, and angular momentum emerges naturally from the way mass aggregates. The surprising thing is not that galaxies spin. The surprising thing is how consistent their spins become across enormous distances. In some studies, particularly those analyzing Sloan Digital Sky Survey data, certain regions exhibit a slight preference for clockwise or counterclockwise galaxy spins. The asymmetry is small, measured in single-digit percentages, yet its statistical significance hints at a deeper coherence. While the scientific debate continues, some argue selection effects or survey biases may cause the signal. Others have explored theoretical models that could explain a primordial handedness. Chiral gravitational waves, asymmetric inflationary potentials, or even coupling between scalar and pseudoscalar fields in the early universe might generate a universal twist. If such mechanisms shaped the cosmos, then the spinning of galaxies would not merely be a consequence of local tidal torques. It would be a signature of the universe's own orientation. Let yourself consider that possibility, not as a dramatic revelation, but as a quiet, almost meditative idea. A universe born with a whisper of rotation, a faint preference, a soft directionality, so subtle that only when billions of galaxies align do we begin to detect it. This is not the kind of turning you could feel or see. It is not a swirl or whirl. It is more like a distant echo resonating through cosmic time, shaping structure with a hand lighter than breath. But even if no primordial twist exists, the local physics of structure formation still create remarkable coherence. When matter collapses along a filament, galaxies forming within that same filament often align their spins with the filament's axis. The inflow of gas, guided by gravity, tends to rotate in similar ways, creating families of galaxies with shared orientations. Even satellite galaxies orbiting larger hosts, such as those around the Milky Way and Andromeda, exhibit planar structures suggestive of a common rotational origin. These alignments tell stories of accretion histories, mergers, tidal encounters, and the shaping influence of dark matter's invisible framework. And still, no matter how vast the scale becomes, the same principle repeats itself. Once motion begins, it persists. Angular momentum is not merely conserved, it is amplified by collapse, stabilized by gravity, circulated through encounters. The universe, left to its own devices, spins. Imagine now drifting into the heart of a massive star during its quiet midlife. Deep inside, nuclear fusion burns steadily in the core. Energy radiates outward, pushing against the inward crush of gravity. The star rotates, though not uniformly. Its equator may spin faster than its poles, creating differential rotation. This shear helps drive stellar dynamos, generating magnetic fields that shape star spots, solar cycles, and the bursts of charged particles that sweep through interplanetary space. Without rotation, a star's magnetic complexity would fade, its cycles flatten, its interactions with surrounding planets diminish. And when that star eventually dies, rotation shapes its final act. If it collapses into a neutron star, conservation of angular momentum intensifies its spin to unimaginable speeds. Some neutron stars rotate hundreds of times per second. Their magnetic fields, twisted by this extreme rotation, emit beams of radiation that sweep across space like lighthouse beams. These pulsars, observed by radio telescopes around the world, are among the most precise clocks in the universe. Their stability so extraordinary that they help detect gravitational waves from distant, supermassive black hole pairs. All of this precision, this humming regularity, arises from rotation. If the star collapses further into a black hole, the story grows even more extreme. A rotating black hole drags space-time around with it, creating a region outside the event horizon where nothing can remain still. This dragging produces energy extraction mechanisms, like the Penrose process or the Blandford-Znajek effect, which help power the immense jets seen erupting from active galactic nuclei. These jets can launch at nearly the speed of light, piercing intergalactic space for hundreds of thousands of light-years. Their direction, collimation, and stability all bear the signature of the black hole's spin. Without rotation, they would not exist. Galaxies would evolve differently, deprived of the feedback and heating that such jets provide. Now return again to the scale of atoms, and let the quiet precision of quantum mechanics unfold. The spin of an electron is not rotation in the everyday sense. It is a form of angular momentum built into the particle's quantum state. Though it has no classical analog, its behavior is revealed through magnetic interactions. In MRI machines, nuclear spin alignment interacts with magnetic fields to create images of the human body. In quantum computing, spin states of electrons or nuclei serve as qubits, storing information in coherent superpositions. The most sensitive experiments in the world, attempts to detect dark matter or measure tiny violations of fundamental symmetries, often involve manipulating spin at temperatures near absolute zero. Spin is so central to the workings of the quantum world that, if you removed it, matter would become unrecognizable. Electrons would not stack into shells, atoms would have no shapes, molecules would collapse, and chemistry itself would dissolve. The solidity of your surroundings, the warmth of your breath, the synaptic signals flowing through your brain, all depend on quantum rotation. Let that settle in. The same principle that preserves the spin of galaxies preserves the structure of your body at the smallest scales. The same conservation law that guides the cosmic web guides the architecture of atoms. The same symmetry that keeps Earth turning keeps electrons aligned. Rotation, in this sense, is not just a motion. It is a bridge between realms that seem unrelated, the cosmic and the intimate, the vast and the microscopic, the cold emptiness of space and the warmth of your own living breath. And now imagine the quiet paradox at the center of all this. You feel still. In this moment, in this room, your body rests as though no motion touches it. But stillness is a perspective, not a state. You are part of rotation so smooth, so ancient, so perfectly balanced that you cannot detect them. The Earth spins steadily beneath you. The moon orbits. The planet orbits the sun. The sun moves through the Milky Way. The Milky Way drifts through the cosmic web. And the cosmic web itself expands with the universe. You do not feel any of this, yet it defines the world you live in. The quiet of your room is carried by motion. The calm in your body is shaped by angular momentum. The stability of atoms, planets, stars, and galaxies is held in place by the universe's refusal to stop spinning. In the deep background of everything, the universe continues its vast, gentle turning. And, as you drift even further into this unfolding quiet, let yourself imagine the universe not as a static expanse but as a vast, interlinked rotation machine, where every scale echoes the next in a kind of cosmic resonance. Though the connections are subtle, they carry the same mathematical heartbeat, angular momentum conserved, reshaped, shared, but never erased. This is the silent law humming through galaxies and atoms alike. Picture a time long before the Earth existed, when the solar nebula was nothing more than a swirling disk of gas and dust. Within that disk, rotation was not merely inherited, but actively sculpted. Magnetic fields threading through the nebula interacted with charged particles, redistributing angular momentum outward. This process, known as magnetic braking, allowed the central region to collapse into the Sun, while the outer regions flattened into a protoplanetary disk. Even in these earliest stages, rotation determined which regions would form planets, which would remain as belts of debris, and how material would mix over millions of years. Without this gentle exchange of angular momentum, this cosmic bookkeeping, no planets would emerge with stable paths. Jupiter and Saturn would not dominate the outer solar system. Earth would never have acquired the orbital serenity that allows life to take root. And when those planets solidified, their spins continued to evolve. Gravitational interactions nudged them, collisions altered their rotation rates, and tidal forces sculpted their axial tilts. Uranus, tilted almost entirely onto its side, whispers of a colossal impact early in its history. Mars's slower spin suggests a different evolutionary path, shaped by its smaller size and weaker core dynamics. Mercury rotates 3 times for every 2 orbits around the Sun, locked in a resonance that betrays the complex interplay of tidal torques acting over billions of years. Each planet's rotation is a diary of its past, written in the slow turning of worlds. Now drift outward again, to the grand scale of galactic halos, where dark matter dominates. Though invisible, dark matter determines how galaxies spin by shaping the gravitational wells into which gas falls. If the halo has a slight anisotropy, or if material accretes along preferred filaments, the resulting galaxy inherits that directionality. Over cosmic time, Mergers add new angular momentum or redirect old flows, but the underlying coherence remains. Even as galaxies collide and distort, their spins reorganize into new structures, maintaining the unbroken chain of conserved motion. And yet, amid this immense predictability, the universe allows for subtle surprises. Consider the phenomenon of galaxy spin flips. Simulations show that galaxies can suddenly reorient their rotation axes by tens of degrees when major mergers occur, or when gas flows shift along filaments. These flips, though rare on human timescales, shape the long-term evolution of galaxies. A spiral galaxy may realign itself, altering the orientation of its disk, its spiral arms, its star-forming regions. These transformations unfold over hundreds of millions of years, too slow to witness, yet undeniable when comparing ancient galactic populations. From the perspective of your quiet room, these vast rotations might feel immeasurably distant, but the same physics echo within you. The angular momentum of electrons shapes the bonds that create the water in your cells, the proteins in your muscles, the neurotransmitters that drift through the synapses in your brain. Your thoughts themselves rely on the exquisite organization of matter made possible by quantum spin. And the rhythms of your day, your sense of morning and evening, your cycles of waking and resting, are tied to Earth's rotation. Without that 24-hour turn, life would adapt to a very different pattern. Circadian rhythms in plants, animals, and humans are entrained to the light-dark cycles created by our planet's spin. Even your metabolism, your sleep cycles, and your internal sense of time reflect the gentle rotation of Earth beneath you. Now imagine, just as a thought experiment, a moment in which Earth's rotation slows dramatically. Over billions of years, tidal forces with the moon will continue to lengthen our days, but imagine a far future where Earth becomes tidally locked, presenting one face to the sun at all times. One hemisphere would be scorched in perpetual daylight, the other frozen under endless night. Winds would roar between these extremes, driven by temperature imbalances. Life, if it survived, would huddle in the terminator region where twilight never ends. The simple turning of our world, something we rarely think about, is a stabilizing force that moderates climate and spreads heat across the globe. Rotation is part of why you have gentle nights like this one, rooms filled with balanced warmth, seasons that pass with a familiar rhythm. Let yourself slide deeper into this understanding. Rotation is not just movement. It is a structure maker. It is a balancer. It is a quiet architect shaping everything from planetary atmospheres to the cosmic web. Even meteorology bears this signature. Earth's rotation generates the Coriolis effect, which curves the paths of winds and ocean currents. Hurricanes spin because of it. Jet streams form because of it. Weather patterns across continents arise from a dance between solar heating and planetary rotation. Remove the spin, and the atmospheric systems familiar to you would dissolve. The world would become a planet of extremes, lacking the swirling, self-organizing patterns that create rain, winds, and storms. Now, soften your focus and imagine drifting into the space between galaxies, where gravity quiets and the background becomes a thin mist of particles. Even here, rotation leaves its fingerprints. The largest structures in the universe, the cosmic voids, expand not only because of the overall expansion of the universe, but also because of the flows of matter away from their centers. These flows respond to the rotations and gravitational pulls of surrounding filaments. The voids stretch and reshape over billions of years, subtly influenced by the spins of galaxies far beyond their borders. And beyond even these colossal patterns lies the deeper question: could the universe as a whole be rotating? This idea has tantalized physicists since the time of Kurt Gödel, who discovered solutions to Einstein's field equations that describe rotating universes. In a rotating cosmos, inertial frames twist, and the paths of particles curve even in the absence of gravitational gradients. But observations of the cosmic microwave background reveal no evidence of such global rotation. The universe, on its largest scales, appears remarkably isotropic, equally smooth in all directions. Yet the absence of global rotation makes the presence of local rotation all the more striking. The universe does not need to spin as a whole to give rise to a tapestry of turning woven from the bottom up. Now, drift to the threshold where quantum physics and gravity meet, where the Planck scale sits like a boundary beyond which our current understanding dissolves. At these tiny scales, space-time may not be smooth but foamy, filled with minute fluctuations. Some theories suggest that angular momentum could behave differently near this boundary, or that spin networks, as described in loop quantum gravity, form the discrete scaffolding of space-time itself. If true, then rotation would not simply exist within space-time. It would contribute to the construction of space-time. Feel how softly these ideas settle when you let them. Spin as a fundamental element of reality. Rotation as a through line from the smallest quanta to the largest filaments of galaxies. A shared language spoken across scales so vast they could never physically communicate, yet built on the same mathematical foundation. And now return gently to yourself, to this room, to the quiet that settles in the corners and softens the walls. You are part of these rotations. You are held within them. Every moment of your life is wrapped inside motions so ancient and so steady that they become invisible. Yet they shape everything familiar, every breath, every thought, every star that has ever shone in the night. The universe spins because it was born with the capacity to move, because symmetry allows it, because gravity sculpts it, because conservation protects it, and because nothing in physics ever truly welcomes stillness. The turning continues, quietly, patiently, endlessly, and as you drift further into this quiet unfolding, imagine the entire universe as a vast symphony of conserved motion, where each rotation, no matter how small, adds its own subtle note. No single spin dominates the melody, yet together they create a coherence that stretches across time and distance. It is as though the universe hums a gentle refrain shaped by angular momentum, a whisper carried through stars, atoms, galaxies, and the silent spaces between. Let yourself trace the origin of one of these notes, the rotation of a single atom in your body. Its electrons occupy orbitals defined by quantum numbers that include angular momentum, shaping the probability clouds that determine the atom's geometry. These geometries form the molecular scaffolds inside your cells, from DNA's spiraling helix to the folded proteins performing countless reactions. Life's chemistry depends on these shapes, and these shapes depend on quantum spin. Without rotation at the smallest scales, the elegant architecture of living matter would collapse into sameness. And now follow that same theme outward, where the rotation of Earth defines your sense of day and night. The 24-hour cycle sets the rhythm for circadian clocks within your cells. These clocks regulate sleep, metabolism, mood, and cognition, all synchronized to the planet's steady turning. Even as you lie here in stillness, your internal rhythms are guided by the slow spin of the world beneath you, a world that has rotated billions of times since its birth. Earth's spin is gentle but foundational, shaping life through light and shadow, warmth and coolness, waking and resting. Now drift into the space around Earth, where satellites orbit along paths shaped by both gravity and the planet's rotation. The rotation creates an equatorial bulge, altering Earth's gravitational field and causing satellite orbits to slowly precess. This subtle effect, known as nodal regression, must be accounted for when designing global positioning systems. Without understanding Earth's rotation, GPS would drift, navigation would falter, and the delicate precision we take for granted would dissolve into error. Even the time signals transmitted by GPS satellites rely on relativistic corrections that account for Earth's gravitational field, its rotation, and the effects of motion on time. The stability of our technological world rests quietly on spinning foundations. Let your thoughts float higher still, where the rotation of the Sun shapes the heliosphere, our solar system's protective bubble carved into the interstellar medium. The Sun does not rotate as a solid body. Its equator spins faster than its poles in a pattern known as differential rotation. This uneven turning drives the solar dynamo, generating magnetic fields that wax and wane over an 11-year cycle. Solar flares, coronal mass ejections, and the solar wind all arise from this magnetic complexity. These phenomena shape space, weather, influencing the auroras that glow over Earth's poles, the safety of astronauts, and the performance of satellites. Rotation, again, becomes an architect of environment. Now, follow the solar system outward, past Neptune and the Kuiper Belt, into the realm of scattered icy worldlets. These distant objects orbit within a rotating frame shaped not only by the Sun's gravity, but by the collective history of every gravitational encounter the solar system has experienced. Some of these objects carry spins altered by collisions billions of years old. Others rotate in slow, ponderous cycles that hint at internal structures or past tidal interactions. Each one is a small record of the universe's turning. Beyond these distant worlds, the Sun's gravity thins into the interstellar medium, and the solar system moves as a single unit around the Milky Way. Our galaxy rotates once every 230 million years, a period so long that only a handful of complete orbits have passed since Earth formed. As the Sun travels around the galactic center, it carries with it the legacy of angular momentum from the Milky Way's birth cloud. The spiral arms you imagine when you picture the galaxy are not fixed structures, but patterns emerging from stars orbiting at different speeds. These patterns, known as density waves, maintain their shape because of coordinated motion, the same way standing waves emerge on a vibrating string. Rotation gives the galaxy form, coherence, and longevity. Continue drifting outward, where clusters of galaxies rotate in vast, shimmering halos. Observations of clusters like Perseus and Coma show gas swirling in patterns that reveal rotational motion extending millions of light years across. Simulations confirm that as clusters grow through mergers, they accumulate angular momentum. This spin affects how gas cools, how galaxies orbit, and how active galactic nuclei regulate star formation. Even on these immense scales, rotation is not incidental. It is a guiding influence that shapes the evolution of cosmic ecosystems. And beyond these clusters, where the cosmic web stretches into delicate filaments. Rotation weaves through the largest structures ever observed. Matter flows along filaments toward nodes where clusters form, and these flows impart spin to everything they touch. When galaxies fall into these nodes, they often align their rotation axes with the filaments that fed them. This alignment is part of why many galaxies share a preferred direction, not by coincidence but by inheritance from the cosmic web. In this way, rotation becomes a shared ancestry connecting galaxies across millions of light years. Now, return to the early universe again, but from a different angle. In the moments after the Big Bang, matter and radiation were tightly coupled, forming a hot plasma. Tiny quantum fluctuations grew, creating regions that expanded slightly differently from their surroundings. If any of these fluctuations contained rotational modes, they would imprint a faint sense of direction into the fabric of space-time itself. Though current observations have not confirmed such a primordial rotation, neither have they fully excluded the possibility. Experiments hunting for B-mode polarization in the cosmic microwave background are searching for exactly these signatures, hoping to detect the tiny fingerprint of rotational fields from the first trillionth of a second. This possibility brings you back to the deepest question. Why does anything turn at all? Why does the universe permit rotation so freely, embed it so thoroughly, and protect it so fiercely? The answer lies in symmetry, specifically rotational symmetry. If the laws of physics do not change when a system is rotated, then angular momentum must be conserved. This principle is one of the most beautiful cornerstones of modern physics, linking symmetry to motion in a way that feels both inevitable and elegant. It means that as long as the universe maintains its rotational symmetry on the most fundamental level, turning will remain a universal truth. And now consider the opposite. What if this symmetry were broken more strongly than we observe? What if angular momentum could be dissipated the way energy is lost to friction? In such a universe, structure would have no reason to persist. Galaxies would collapse inward. Stars would shed their rotation and perhaps evolve differently. Planets might be born still, lacking the cycles that shape climate and biological rhythms. Atoms would remain unchanged, protected by deeper quantum rules, but the macroscopic world would be eerily static. Without rotation, the universe would lack the dynamic architectures that give it texture and complexity. You live in a universe that chooses motion over stillness, continuity over stagnation, curvature over flatness. And though this motion is everywhere, it rarely calls attention to itself. It hides in the quiet. It folds itself into the background of your experience. It becomes the stage rather than the actor. Now return to this moment, to your breath, to your body resting within the turning world. Imagine feeling the deep, almost imperceptible rotation of Earth beneath you. You cannot sense it directly, yet you are carried by it. Imagine sensing the slow orbit of Earth around the Sun around the galaxy drifting through the cosmos. These layered motions cradle you in a vast, gentle flow. And beneath them all, the rotation of atoms holds you together. Everything that turns with purpose shaped by the laws of physics. Everything that turns, because nothing in the universe is perfectly still. Everything that turns because angular momentum binds the cosmos into structure, rhythm, and continuity. The universe keeps spinning, quietly, patiently, endlessly. And as you drift deeper into this soft unfolding of motion, Imagine the universe not as a collection of isolated spinning objects, but as a continuous fabric of rotation where every turning body leaves a subtle influence on the space around it. This influence is not always something you can see, but it is always there, shaping orbits, bending paths, stirring magnetic fields, and curving time itself. Rotation weaves a quiet thread through every level of reality. Feel how this thread stretches all the way back to the first stars. When the earliest generations of stars formed, massive, metal-poor giants known as population 3 stars, they ignited within dense pockets of primordial gas. These clouds, too, carried angular momentum inherited from the early universe, which helped regulate the star-forming process. The rotation of these early clouds influenced the fragmentation of gas, determining whether a single massive star formed or a cluster of smaller ones emerged. Rotation acted as a stabilizing force, pushing back against gravitational collapse just enough to shape the first stellar nurseries. And those stars, in turn, seeded the universe with heavier elements when they died in explosive supernovae, scattering the building blocks of future planets and life. Even the elements within your blood and bones owe their existence to the turning motions of long-extinct stars. Now, imagine drifting into a star-forming nebula, where rotation takes center stage again. Gas and dust collapse under gravity, but because of conservation of angular momentum, the cloud flattens into a disk. This disk becomes the birthplace of new stars and planets, spinning gently around a forming protostar. Within these disks, smaller eddies form, creating regions of enhanced density that will one day become planets. The direction of the disk's rotation sets the direction of planetary orbits. The architecture of entire solar systems, whether they form hot Jupiters, compact super-Earth chains, or widely spaced giants, depends on angular momentum redistribution within these swirling environments. And even long after the planets have formed, rotation continues to shape their fates. Consider Saturn's rings, those delicate, shimmering bands of ice and rock. They are not static ornaments, but dynamic, rotating systems where particles orbit with graceful precision. Wave patterns ripple through the rings, created by gravitational resonances with Saturn's moons. These resonances arise because of orbital motion, itself a form of angular momentum. Without rotation of Saturn, of its moons, of the ring particles, this ballet of structure would collapse. Now, gently lift your mind to the level of stellar remnants. When massive stars die and leave behind neutron stars or black holes, their rotations become extreme. A neutron star with the mass of our Sun compressed into a sphere only 20 kilometers wide can spin hundreds of times each second. This rotation is so rapid that the star becomes an oblate spheroid, flattened at the poles. The magnetic field lines twist around the star, channeling charged particles into beams of radiation. These beams sweep across the cosmos like lighthouse beams, creating the pulsar signals detected by observatories around the world. Pulsars are among the universe's most precise clocks, their timing so stable that even gravitational waves, tiny ripples in space-time, can be detected by monitoring slight deviations in their rhythms. Their rotational stability is a gift to physics, a cosmic metronome ticking across millions of light years. As you drift even deeper into this narrative, imagine now a rotating black hole. Unlike a static black hole, whose only defining characteristic is its mass, a rotating black hole has an additional parameter, its angular momentum. This rotation drags space-time around with it, creating a region called the ergosphere where nothing can remain at rest. Particles entering the ergosphere can be split, with one fragment falling into the black hole and the other escaping with more energy than it entered. This process, known as the Penrose process, allows the rotational energy to be extracted from the black hole. In this way, rotation becomes a reservoir of power, driving jets and shaping the evolution of galaxies hosting active galactic nuclei. And yet, beneath all these magnificent expressions of rotation, the universe maintains an almost poetic simplicity. Angular momentum cannot be destroyed. It moves, it reshapes, it transfers, but it does not vanish. When stars collapse, their rotation intensifies. When galaxies merge, their spins combine and redirect. When gas flows along filaments, it picks up the rotational imprint of its path. Motion becomes lineage, passed from one generation of cosmic structures to the next. Now drift into the cosmic web once again, but this time imagine it in motion. Filaments twisting softly, nodes rotating slowly, voids stretching outward as matter flows away. This is not the dramatic motion of whirlpools or storms, but the quiet turning of a structure governed by gravity and shaped by billions of years of evolving mass distributions. The cosmic web is not static. It is alive with movement, subtle and ancient. Its rotational modes evolve as clusters merge, as dark matter halos grow, as gas cools and condenses. Even the largest voids expand asymmetrically, influenced by the surrounding rotations of galaxies and clusters. And beneath the cosmic web lies something even more profound, the symmetry of space-time itself. In Einstein's general relativity, space-time responds not just to mass and energy, but to angular momentum. Rotating bodies cause frame dragging, a phenomenon confirmed by experiments such as Gravity Probe B. This dragging effect, though incredibly small on Earth, becomes significant near massive rotating objects like neutron stars and black holes. It reveals that rotation is not merely an object's property, it is a property of space-time, woven into the curvature of the universe. Now, step back from the cosmic scale and bring your awareness to the quiet inside this moment. Your sense of stillness is real, yet it exists within layers of motion you can scarcely imagine. The atoms in your body rotate in quantized whispers. The Earth turns beneath you at hundreds of meters per second. The planet orbits the Sun at tens of kilometers per second. The Sun moves through the galaxy at 200 kilometers per second. The galaxy drifts through the cosmic web at even greater speeds. And all of these motions, combined, create the gentle environment in which you rest. The stillness you feel is the harmony of being carried by these motions rather than resisting them. You are not separate from the turning universe. You are wrapped inside it. Now imagine, just for an instant, the impossible. A universe where all this turning stops. The atoms freeze into shapes that violate their own rules. Magnetism dissolves. Stars lose their balance and collapse or expand uncontrollably. Planets drift into unstable paths. Galaxies fold inward. Black holes shed their ergospheres. Timekeeping falters. Weather patterns fail. Climates destabilize. Life struggles under skies that no longer follow familiar cycles. But our universe is not such a place. Rotation is protected by symmetry, and symmetry is protected by the fabric of physical law. The universe prefers continuity. It prefers persistence. It prefers the rhythm of motion over the silence of stillness. And in this gentle, endless turning, you find a reflection of your own experience. Your breath rises and falls. Your thoughts spiral inward and outward. Your memories circle around moments of meaning. Even your sleep cycle follows a rotation traced in biology and light. The universe spins, and you spin within it, quietly, naturally, effortlessly. Everything that turns continues turning, carrying you deeper into the soft, ancient rhythm that has guided the cosmos since its first whisper of existence. And now, as the night around you deepens into something softer, imagine the earliest galaxies forming in a universe still warm with its first light. Their shapes were irregular at first, clumps of stars held loosely in gravitational embraces. Yet even these primitive structures carried rotation, a faint imprint of the tidal torques that shaped them. As they merged, collided, and reassembled, their spins intensified or shifted. Angular momentum wove itself into the bodies of these young galaxies, guiding the formation of disks, bulges, and halos. Over billions of years, these once chaotic motions settled into the graceful spirals we recognize today. Drift closer to one of these spirals. Feel the calm sweep of its arms as they rotate around a dense, glowing core. Stars orbit along paths defined by gravity, but their collective behavior is shaped by rotation. The galaxy's flatness, its disk-like geometry, emerges because of the conservation of angular momentum during its formation. Gas clouds moving within this rotating frame encounter shock fronts in the spiral arms, triggering new waves of star formation. These stars inherit the motion of the disk, and the process continues, generation after generation. Rotation becomes the quiet architect of galactic evolution, determining how stars form, how gas flows, and how galaxies develop their luminous shapes. Now imagine falling gently into the spaces between these rotating disks, into the dark matter halos that cradle them. Dark matter, though unseen, is the anchor of galactic rotation. Without it, galaxies would spin apart. The observed rotation curves would not hold. Instead, stars in the outer regions would fly away because there is too little visible mass to bind them. Yet dark matter's quiet presence supplies the missing gravitational support, allowing galaxies to keep their shape. Simulations reveal that dark matter halos themselves can carry angular momentum, inherited from the early tidal torques of the universe. These halos twist subtly as they grow, guiding the formation of the galaxies nestled within them. Rotation is not merely a feature of luminous matter, it is a characteristic of the entire cosmic structure. Let yourself drift further into this realization. Rotation is not something objects choose. It is something they inherit, something given to them by the environments from which they form. The universe's rotation is passed down through generations of structure, carried forward by gravity, preserved by symmetry. Nothing in physics asks an object to spin. The laws simply prevent it from stopping. And now, imagine being suspended near the event horizon of a rapidly rotating black hole. Space and time swirl together, warped into a funnel of curvature. Frame dragging pulls everything into motion, even if it did not begin that way. Light itself spirals inward. Magnetic fields twist, accelerating particles into streams of radiation that shoot out along the black hole's poles. You are witnessing one of the most extreme expressions of rotation in the cosmos, where angular momentum becomes a force capable of sculpting entire galaxies. The jets launched from rotating black holes heat interstellar gas, regulate star formation, and shape the evolution of the galaxy that hosts them. Without spin, black holes would be quieter, less influential, and galaxies would grow unchecked. Rotation maintains balance in the cosmic ecosystem. Now drift outward again, beyond any single black hole, beyond any single galaxy, into the vast cosmic web. Here, rotation becomes so subtle you can only trace it statistically in the preferred alignments of galaxies, in the twisted shapes of filaments, in the motions of clusters. The universe at this scale behaves almost like a fluid, with eddies and flows shaped by gravity's long reach. Rotation emerges naturally where matter collapses unevenly, where filaments feed clusters asymmetrically, where tidal fields warp the shapes of halos. It is as though the universe breathes through these vast rotations, inhaling material along filaments and exhaling angular momentum across cosmic timescales. And yet, beneath all of this, quantum mechanics hums with its own rotations. Electrons, protons, and neutrons carry intrinsic spin, a quantum number that cannot be removed, altered, or imagined away. This spin defines how particles combine, how atoms form, how magnetic materials behave. It shapes the underlying rules of chemistry and physics. Even the photons that illuminate the universe carry angular momentum when they twist their polarization, a property exploited in technologies from laser optics to quantum communication. The universe, at every level, is a tapestry of spin. Now, imagine gently setting aside the vast scales of galaxies and clusters and returning to something intimate, a single moment of stillness within your own breath. As you rest, the world around you seems unmoving. But that stillness is woven from motions so smooth and ancient that they become invisible. You live inside a rotating atmosphere, shaped by the Coriolis effect. You sleep beneath a spinning sky. You rest within a universe that has never stopped turning, not for a single heartbeat of cosmic time. Your body, too, is aligned with this rhythm. Your cells operate with molecular machinery shaped by quantum spins. Your circadian rhythms synchronize with Earth's rotation. Your heartbeat flows through cycles. Your thoughts spiral in loops that return, evolve, and return again. Within you, rotation becomes metaphor as well as physics, a way of understanding the repeating patterns of life, the cycles of memory, the gentle spirals of thought that carry you toward rest. And now imagine the far future of the universe, trillions of years ahead, when star formation has slowed to a whisper, when galaxies have merged into enormous elliptical structures and the night sky grows sparse. Even then, rotation persists. The remnants of black holes will continue to spin, neutron stars will continue their quiet rotations, and the orbits of planets, where they still exist, will trace ancient paths. Angular momentum becomes one of the last preserved features of a fading cosmos. Even as energy dissipates, as stars cool, as galaxies dim, rotation remains because symmetry does not age. The universe may grow cold, but its turning does not forget itself. And beneath all of this, a simple truth unfolds. The reason everything spins in the same direction is not because of a command written at the universe's beginning, but because of gentle inheritances shared across time. Matter collapses with small asymmetries. Gravity amplifies them. Tidal torques align them. Filaments guide them. Conservation protects them. And so the universe becomes a place of coherent turning, where galaxies spin in preferred orientations, where stars rotate with their disks, where planets orbit in familiar planes, and where the atoms in your body follow quantum rules shaped by an unbroken lineage of spin. You are part of this lineage. You are held in its continuity. You are carried by rotations that began long before Earth formed, long before the sun ignited, long before the Milky Way assembled itself from clouds of dark matter and gas. The turning of the universe is not something you witness, it is something you inhabit, and in the quiet of this moment, it carries you gently, effortlessly, deeper into its soft, ancient rhythm. And now, as the arc of this quiet story continues to unfurl around you, imagine returning once more to the earliest instance of the universe, not the first second or the first fraction of a second, but the first unimaginable shiver of time, when space-time itself had only just begun to unfold. In that brief, delicate moment, the laws that now govern every turning object were already present. Symmetry was already choosing its alignments. Conservation principles were already whispering their quiet promises. And from that moment onward, the universe would never again know true stillness. Let yourself settle gently into that idea. Before galaxies, before stars, before atoms, before light loosened itself from matter, the very geometry of space-time carried the potential for rotation. Quantum fields trembled with fluctuations that would later grow into the seeds of cosmic motion. Inflation stretched these microscopic jitters into macroscopic imprints, shaping the scaffolding of all future structure. These faint variations in density, temperature, and curvature would eventually become the architecture of the cosmic web. And wherever asymmetry existed, however slight, rotation followed. Now drift to a time just after inflation, when the universe was filled with a hot plasma of particles and radiation. In this dense, glowing sea, early turbulence may have carried rotational modes, tiny curls of motion preserved in the fluid-like behavior of the young cosmos. These primordial curls would have been smoothed by expansion, yet never fully erased. Some theories suggest they might have seeded the spin of protohalos. Others propose that quantum fluctuations in vector fields could have laid a foundation for universal handedness. These possibilities remain subtle, analytical, almost whispered, but they point to a profound truth. The universe's vast turning may descend from the quiet complexity of its earliest breaths, and then the universe cooled, particles combined, atoms formed, light decoupled from matter, spreading outward to become the cosmic microwave background. In that moment, rotation was still too small to see, too quiet to detect. But the seeds were there, waiting for gravity to amplify them. Now drift forward to the epoch of Ryanization, when the first stars and galaxies ignited across the darkness. As matter collapsed under gravity, it carried forward the faint rotational signatures imprinted upon it. Protohalos twisted gently as gas flowed inward along filaments. Early galaxies formed disks or distorted shapes based on how angular momentum accumulated. The same physics that guided these motions would later guide the formation of planets, moons, weather systems, and the molecular patterns in your body. From these earliest galaxies, the universe learned how to turn. Now, shift your attention to the role that gravity plays in this cosmic choreography. Gravity is indifferent to direction. It pulls inward the same way no matter which way matter spins. But because of angular momentum conservation, collapsing systems inevitably flatten into disks, form spirals, and generate coherent rotation. Even the shape of the Milky Way, with its grand arms sweeping outward, emerges from gravity's interplay with rotation. If rotation vanished, galaxies would not be disks. They would collapse into featureless spheres. Their beauty, their structure, their long-lived spirals, all of it arises because conservation of angular momentum prevents matter from falling straight inward. In this sense, rotation is the universe's way of balancing gravity. A quiet balancing, not a battle. A soft equilibrium born of symmetry, not struggle. Rotation keeps galaxies from collapsing, keeps stars from imploding too quickly, keeps planets in stable orbits. It is the soft counterweight to gravity's pull. And now, let your awareness drift to the scale of the solar system again, where you can feel how rotation unifies structure. The planets orbit the Sun in nearly the same plane and in the same direction. This coherence is not coincidence, it is inheritance. The solar system was born from a rotating disk, and that disk was born from a rotating cloud, and that cloud inherited its spin from tidal interactions with the galaxy. Every orbit traced by every planet is a continuation of angular momentum transferred across cosmic epochs. If everything in the universe appears to spin the same way, it is because they all emerge from related structures, all shaped by similar processes, all guided by the same conservation laws. The universe is not enforcing uniformity. It is simply carrying forward the motions it began with. Now, step softly into the space between microscopic and cosmic, where rotation shapes phenomena that neither purely classical nor purely quantum descriptions can fully capture. In superconductors, electrons pair into Cooper pairs that move coherently, carrying angular momentum in ways that defy classical expectations. In superfluids, vortices form with quantized circulation, tiny whirlpools governed by the same principles that shape hurricanes and galaxies, yet constrained by quantum laws. These vortices, though microscopic, are remarkably stable. They demonstrate that rotation, when quantized, becomes deeply resistant to change. This stability echoes across scales, revealing that the universe treats rotation with a kind of reverence. Gently follow that echo back into astronomy. When stars form within molecular clouds, rotation prevents total collapse, causing the cloud to fragment. This fragmentation leads to star clusters, binary star, systems, and planets forming around multiple suns. Angular momentum shapes not only individual stars, but the very architecture of stellar populations. The galaxy around you is filled with these structures, groupings, associations, families, all shaped by rotation. Now, imagine drifting near a double star system where two suns circle each other. Their orbits are governed by shared angular momentum. Some pairs revolve slowly, taking centuries to complete an orbit. Others whirl around with blistering speed. Their rotations shape tidal forces, drive mass transfer in close binaries, and even determine whether one star will strip material from the other in a dramatic exchange of matter. Rotation is at the core of their relationship, guiding their evolution from birth to death. And now lift your mind to clusters of stars and globular clusters, tight, ancient gatherings of tens of thousands of stars bound by gravity. These clusters exhibit subtle rotational signatures that reveal their histories. Even here, in these nearly spherical systems, rotation leaves an imprint. Some clusters rotate rapidly, others turn slowly. Their rotation influences how stars migrate within them, how they evolve dynamically, how they eventually dissolve back into the galactic halo. Now drift outward to the local group of galaxies, the Milky Way, Andromeda, and dozens of smaller companions. Their motions around one another, their future merger, their shared orbital dance across billions of years, are all shaped by angular momentum. When the Milky Way and Andromeda finally merge, their spins will reorient into a new structure, possibly forming a massive elliptical galaxy. Yet, even as their forms change, their combined angular momentum will persist. Motion may transform, but it will not cease. And now, return to the quietest, most personal corner of this cosmic story, your own experience of rest. As you lie here, everything around you feels still. The walls do not move. The air is calm. Your breath rises and falls in gentle cycles. This stillness is not the absence of motion, but the presence of harmony within it. You are moving with the earth, not against it. You are being carried by cosmic rotations so steady, so smooth, so ancient, that they cradle you rather than disrupt you. The universe does not spin chaotically. It spins coherently, patiently, in patterns that echo across scales. You live inside those patterns. You rest inside those patterns. Even now, as your awareness softens, you are drifting on a tide of motions older than the stars. In all the layers of your existence, from the electrons in your atoms to the galaxy that shelters your sky, rotation is the thread that binds structure to stability, motion to meaning, past to present. Everything turns because the universe remembers its beginnings, and everything continues turning because the laws of nature hold those beginnings gently in place. The turning carries you, carefully, quietly, endlessly. And now, as the eyes universe around you continues its vast and ancient turning, imagine drifting into a place where rotation becomes not just motion, but memory, an imprint carried forward from the earliest trembling of space-time, all the way into this quiet moment where you rest. Every spin you have traced through this journey, from electrons to galaxies, is part of a single continuous lineage. A cosmic inheritance passed from scale to scale, from epoch to epoch, from the birth of the universe into the architecture of everything you know. Let your awareness settle into the idea that rotation is not added to the universe. It emerges from it. It is the natural consequence of conservation laws written into the bedrock of physics, laws that shape the behavior of particles and planets with the same unwavering commitment. Angular momentum becomes a thread of coherence, ensuring that motion persists even as structures evolve, collide, merge, and transform. Now, soften your focus and imagine watching a small, collapsing cloud of gas in deep space. At first, it seems irregular, unremarkable, drifting quietly among the stars. But as gravity pulls it inward, its faint, almost imperceptible twist begins to amplify. The closer the gas falls toward its center, the faster it rotates, creating a disk, a vortex, a gentle whirl that will one day become a star. The speed increases, not from anything pushing it, but from something conserved, an old promise the universe never breaks. From this spinning disk, planets will emerge. Their orbits will align with the disk's rotation. Their spins will echo that alignment. And if moons form, their movements will remember the motions of the planets that cradle them. From this soft, spinning cloud, a solar system is born. Now drift inward again into the heart of a forming planet. As molten rock cools in layers, convection flows rise and fall, shaped by the rotation of the young world. This rotation guides the formation of magnetic fields, which protect the fragile surface from the solar wind. Without rotation, there would be no magnetic shield. Without a shield, Earth's atmosphere would erode. Without an atmosphere, the surface would be barren, lifeless, exposed. Rotation becomes not just a feature of a planet, it becomes protection, becoming part of why Earth can hold the air you breathe, why oceans can gather, why life can unfold in delicate patterns. And beneath that atmosphere, weather patterns take shape because of rotation. The Coriolis effect curves winds across continents, forming gyres in the oceans, organizing storms into spiraling structures that rise and dissipate as heat moves from one region to another. Without Earth's spin, the atmosphere would circulate more directly, without the soft choreography that gives rise to familiar climates. Rotation becomes a quiet sculptor of seasons, temperatures, rainfall, the gentle patterns that repeat through the year like an unspoken rhythm. Now drift upward again, into the calm cold, space where space stations orbit Earth. These stations rely on orbital motion, a balance between forward velocity and the pull of gravity, to float effortlessly without falling. Astronauts inside experience weightlessness not because gravity is absent, but because they are continually falling around the Earth, carried by a motion so perfectly tuned that it creates the illusion of stillness. Rotation at this scale becomes a form of harmony, a way of moving that maintains equilibrium. Imagine now drifting even farther to watch a binary star system locked in its ancient dance. Two stars orbit one another, their motion shaped by a shared well of gravity. Their spins may influence each other over long timescales, tidally slowing or accelerating one another, shaping their internal convection, changing their magnetic activity. In some systems, the stars exchange mass, creating accretion disks where rotation accelerates gas to immense speeds before it spirals inward. These disks shine brightly in ultraviolet and X-ray light, broadcasting the story of rotation across the cosmos. If you drift still farther, you might observe a supermassive black hole at the center of a distant galaxy. The disk of gas around it rotates so rapidly that friction heats it to millions of degrees. Jets erupt from the poles, driven by twisted magnetic fields and the black hole's own angular momentum. These jets propagate across hundreds of thousands of light years, influencing the growth of galaxies far beyond their origin. Rotation at this scale becomes an engine, a mechanism through which the universe regulates structure and temperature, shaping environments for billions of years. And beyond all of this, the stars, planets, galaxies, black holes, lies the gentle whisper of quantum spin. You cannot see it, you cannot feel it, but everything you are depends on it. Without electron spin, atoms would collapse. Without nuclear spin, the clocks that define time would lose their precision. Without the structured behavior of quantum angular momentum, chemistry would fail, biology would unravel, and consciousness would have no structure to inhabit. Even your thoughts, unfolding one after another, arise from molecules shaped by quantum rotation. The calcium ions that move through neurons, the proteins that fold into enzymes, the DNA that spirals into chromosomes, they all carry the signature of spin. Now drift to the possibility of a universe without rotation. It is almost unimaginable, yet exploring it reveals how deeply motion defines our reality. Without rotation, planets would not hold stable orbits. Stars would collapse more quickly or expand without balance. Galaxies would lose their sweeping arms and collapse into small, compact clusters. Magnetic fields would vanish, stripping the planets of protection. Moons would stop their dances. Winds would falter. Weather systems would fade. Climates would shift into extremes. Even your body would change, as molecular interactions, driven by spin, would behave differently. The entire narrative of existence would flatten. But our universe is not that universe. Our universe chose turning. It chose motion. It chose the generative dance of asymmetry and conservation, shaping everything from the cosmic web to the flicker of a single electron. Now return gently to this moment, where the edges of your awareness soften like distant starlight. You are breathing within a universe that has never stopped moving. You are resting inside layers of rotation so perfect in their harmony that they become invisible. You are carried by a planet, a star, a galaxy, and a quantum architecture all turning together, all contributing to the quiet stability around you. Everything turns because turning is woven into the laws of nature. Everything spins because the universe sustains the memory of its formation. Everything continues spinning because conservation holds the story in place. And you, resting here, are part of that endless turning, held in it, protected by it, shaped by it, drifting deeper into the soft rhythm that has guided the cosmos since its first whisper of time. And now, as you drift even deeper into this quiet current of motion, imagine the entire universe as a vast river of turning, slow in some places, swift in others, but never truly still. This river flows through you as much as around you. Every breath you take is carried within cycles shaped by rotation. Every heartbeat unfolds inside a body built from atoms sustained by quantum spin. Every moment of your life happens inside nested orbits you never feel, yet that guide you with silent precision. Let your awareness rest for a moment on the rotation of Earth itself. The planet turns once every 24 hours, yet that cycle is gradually slowing because of tidal interactions with the Moon. As Earth loses angular momentum, the Moon drifts away by a few centimeters each year. This quiet exchange has been happening for billions of years, sculpting the length of our days, shaping the rhythms of tides, influencing the evolution of coastal life. The slowing of Earth is imperceptible to you, yet it reveals a truth woven through the universe. Rotation moves between objects like a whisper passed from one hand to another, never lost, only shared. Now drift upward, where Earth's rotation interacts with its orbit around the Sun. The tilt of Earth's axis, frozen at about 23.5 degrees because of its rotational stability, creates the seasons. Without this tilt, your world would have no variation in the length of days, no shifting palette of light through the year, no migrations of birds following seasonal cues. The spin of Earth not only shapes your daily experience, but also enriches the tapestry of life around you. Forests grow and rest in seasonal cycles, oceans warm and cool, winds change direction, rain falls in patterns shaped by rotation, by tilt, by orbit, a cascade of motions guiding life's unfolding. Now, imagine drifting across millions of kilometers to the Sun, a sphere of hydrogen and helium turning slowly, carrying plasma in vast circulating flows. The Sun rotates faster at its equator than at its poles, creating shear zones where magnetic fields twist and tangle. Every 11 years, this tangled magnetic tapestry flips its polarity, causing sunspots, flares, and coronal mass ejections. These events ripple through the solar system, shaping the very space through which Earth travels. Even the auroras that shimmer over Earth's poles, soft curtains of light dancing in silence, begin with the Sun's rotation. And as you drift outward, you come to recognize that rotation defines not only stars, but the spaces between them. Interstellar clouds carry turbulence and spin that shape how stars are born. Molecular filaments, threaded with magnetic fields, rotate gently as gravity pulls material inward. Regions of higher density break away, spinning faster as they collapse, echoing the same principles that guide galaxies on far larger scales. Let yourself move now into the halo of the Milky Way, where its vast spiral arms turn like luminous rivers. Each arm is not a solid structure but a pattern, a density wave created by stars moving in and out of regions of higher concentration. The pattern persists because of the galaxy's rotation. Stars orbit at different speeds, yet the arms survive, illuminated by young, bright stars that form in the compressed gas of these rotating waves. Rotation becomes choreography, guiding billions of stars in a dance so smooth and so ancient that you could never sense its movement directly. Continue drifting outward, toward the neighboring galaxies of the local group. Andromeda turns with its own immense grace, its disk inclined to our line of sight, its spiral arms glowing faintly across 2.5 million light-years. In a few billion years, the Milky Way and Andromeda will merge. Their spins, combined and redistributed, will shape the structure of the new galaxy they form. Even across such vast stretches of time, rotation orchestrates a continuity. Now rise above the level of galaxies, into clusters where galaxies orbit a shared center of mass. These orbits trace paths shaped by rotation on scales that dwarf everything familiar. Some clusters show signs of coherent turning, their galaxies drifting through space like leaves in a circular current. Others carry tangled motions, yet even there, rotation plays its role in stabilizing the cluster and shaping the distribution of dark matter. Let yourself drift farther still until you reach the cosmic web, the immense structure linking galaxies and clusters into filaments and voids. Matter flows along these filaments, feeding galaxies and imparting angular momentum. Simulations reveal that filaments themselves twist slowly, their rotation influencing the spin of the galaxies embedded within them. This is why spiral galaxies in certain regions share preferred orientations, why their rotation axes line up across millions of light-years. Not because they communicate, but because they inherit the same ancient motions from the larger structures that cradle them. And now, move inward again into the gentle realm of quantum fields. Here, spin is not rotation through space, but a property of the particles themselves, embedded in the mathematics that govern their existence. Yet, this intrinsic spin produces magnetic moments, influences energy levels, shapes interactions. Quantum spin determines how atoms emit and absorb light, how molecules bond, how stars fuse hydrogen, how life carries information in chemical form. Without quantum spin, the universe would fall silent. No atoms, no chemistry, no stars, no breath. This layering of rotation across scales reveals a quiet truth. Motion defines structure, and structure defines possibility. Now, imagine drifting into the far future, long after the current epoch of stars and galaxies has faded. In that distant time, stars will burn out, galaxies will merge, and the universe will cool. Yet, rotation will endure. Black holes will continue spinning, perhaps the last significant structures in an expanding cosmos. Their spin will persist for aeons, outlasting light, outlasting heat, outlasting the galaxies themselves. Angular momentum will remain as one of the final testaments to the universe's early asymmetries, surviving long after many other physical processes have ceased. And beneath all of these ideas, there is something quieter, something closer to your own experience. You are part of these motions. You are held in their continuity. The stillness you feel is created by harmony, not by rest. You do not sense Earth turning because you are carried perfectly within its motion. You do not feel the sun's orbit because your entire world shares it. You do not sense the galaxy turning because its rotation is distributed across 100 billion stars moving in gentle coordination. You live inside a cosmic cradle that turns so smoothly, so consistently, that stillness becomes possible. And as you rest within this gentle harmony, you can feel the truth settling softly. The universe spins because it began with imperfections, because gravity amplifies motion, because symmetry protects angular momentum, because rotation brings stability to structure. Everything that turns continues turning because nothing in nature erases rotation. It only transforms it. The atoms within you spin. The planet beneath you spins. The stars above you spin. The galaxies around you spin. And the fabric of space-time curves gently around each rotation, acknowledging it, carrying it forward. All of these motions are part of the same quiet lineage, flowing from the first trembling seconds of the cosmos into the soft rhythm of your breath tonight. And you, in this moment of calm, drift within that lineage, held gently by motions older than light. And now, as the quiet around you deepens into something almost luminous, imagine the universe not as a place you observe from the outside, but as a living field of motion you inhabit from within. Every rotation you've traced across this journey is part of a continuous flow, as if reality itself were a tapestry woven from spinning threads. These threads stretch from the smallest quanta to the largest clusters of galaxies, from the hidden spin of electrons to the slow turning of cosmic filaments across billions of light years. And all of them, without exception, share a single quiet truth. Once rotation begins, the universe never lets it go. Let yourself drift gently into that understanding as you imagine, now, the subtle geometry of space-time responding to rotation. In Einstein's general relativity, the presence of mass curves space-time, but the presence of angular momentum twists it. This twisting is gentle around Earth, detectable only by exquisitely sensitive instruments, yet it reveals something profound. Rotation is not merely happening in space, it is happening to space. A turning mass pulls space-time along with it, dragging the very fabric of reality. This frame-dragging effect grows stronger near massive, rotating bodies, like neutron stars and black holes, where space-time can twist so tightly that even light must follow curved paths. In this way, rotation becomes not just a property of matter, but a sculptor of geometry. The universe remembers every spin not as a fleeting motion, but as a subtle reshaping of the stage on which all things move. Now, imagine gliding slowly toward a neutron star, one of the densest objects in existence. It rotates so rapidly that if you could stand on its surface, you would move faster than sound with every single turn. The star's crust, only a few kilometers thick, is locked into an almost crystalline structure by the immense pressure. Beneath it lies a sea of superfluid neutrons, a quantum liquid that flows without resistance. This superfluid carries quantized vortices, tiny, precise whirlpools of rotation, each one anchored to the star's rotation rate. When the neutron star slows, these vortices migrate outward in discrete steps, releasing energy in sudden jumps that astronomers detect as glitches in the star's pulsing rhythm. Even here, in one of the most extreme environments in the cosmos, rotation behaves with quiet discipline. Quantized, conserved, invariant. A star's rotation unfolds like a heartbeat you can observe from light years away. Now drift farther outward again to a galaxy alive with its own rotation. Think of the stars moving through its disk, each one following a path shaped by gravity and anchored by angular momentum. The inner stars orbit quickly, completing their circuits in mere tens of millions of years. The outer stars move more slowly, yet they remain bound in graceful arcs because of the unseen mass of dark matter. Rotation curves, mapped by telescopes, reveal this invisible framework. Without dark matter's quiet grasp, galaxies would spin themselves apart. The rotation you observe here is not chaotic. It is ordered, stable, persistent. Each star moves in a path designed by centuries of cosmic evolution, as if responding to a rhythm set long before it was born. Now drift between galaxies into the quiet gulf of intergalactic space. Even here, rotation leaves its fingerprints. The gas between galaxies does not remain still. It shifts in response to the motions of the structures surrounding it. As clusters grow, they draw in this gas, imparting gentle twists that span millions of light years. These flows create rotational signatures, visible in X-ray observations of hot intracluster gas. Even the voids, the vast, empty regions where hardly any galaxies reside, expand asymmetrically because of the rotational influences of their boundaries. Rotation, wherever you look, becomes a kind of cosmic handwriting. It marks the evolution of galaxies and the quiet breathing of the cosmic web. And now, step inward again, returning to the intimacy of the microscopic world. Quantum spin, though often described in abstract terms, creates more of your lived reality than you might imagine. The electrons that inhabit atomic orbitals follow rules determined by their spin. The Pauli exclusion principle, a cornerstone of matter's stability, exists because electrons cannot occupy the same state if their spins align. This single rule is responsible for the structure of atoms, the periodic table, the diversity of chemistry, and the architecture of every molecule within you. The shape of your DNA, the function of your enzymes, the charges that flow through your neurons. Each depends on the quiet orientation of quantum spins aligned in specific, delicate ways. Without these spins, everything would collapse inward into a featureless cloud of indistinguishable particles. Matter would forget its form. Life would lose its foundation. Now, drift back into the planetary scale, where rotation collaborates with gravity to carve out the shape of worlds. Earth bulges slightly at the equator because of its rotation, altering gravity just enough to shape ocean currents and the paths of satellites. Jupiter, rotating in less than 10 hours, flattens noticeably, its belts and zones arranged in bands because of rotational forces and deep atmospheric flows. Saturn's rings stretch out in near-perfect planes because rotation keeps their particles in orderly orbits. Even the tilt of a planet's axis, influenced by collisions and rotational stability, can determine whether its climate cycles gently or swings into extremes. Rotation here becomes more than motion. It becomes identity. And now imagine gliding outward into the early galaxy that would one day become the Milky Way. In its youth, it was a chaotic place. Gas clouds colliding, star clusters forming and dissolving, dark matter flowing along filaments into its growing halo. Yet, even amid this early turbulence, rotation was quietly organizing the galaxy. Its disk took shape as angular momentum prevented collapse along the plane of rotation. Stars that formed within the disk began their lives in orbits reflecting the galaxy's spin. Over billions of years, this rotation smoothed the galaxy's structure, giving rise to the sweeping arms and calm stellar neighborhoods you know today. The rotational coherence you witness in modern galaxies is not random. It is the end result of billions of years of self-organization. Now, drift outward to the cosmic web, where galaxies align their spins with the filaments that feed them. Imagine a long filament stretching across space, a thread of dark matter and gas. As material flows along this thread, it carries angular momentum into the galaxies forming within it. The galaxies begin to turn with the filament's orientation, creating alignments detectable across enormous cosmic distances. This shared spin direction can persist for billions of years, even as galaxies grow, merge, and transform. And beneath this shared direction lies the oldest story of all. The universe's birth imprinted these alignments into the structure of matter itself. If inflation generated even the faintest hint of rotational anisotropy, so small as to be almost immeasurable, then that hint would echo across cosmic time, guiding the spin directions of galaxies like a memory held in the background of reality. Now, let your awareness drift back toward yourself, to the simplicity of your breathing, the calm of your resting body. You are part of these motions, even if you cannot feel them. The turning of Earth supports your sense of day and night. The orbit of Earth shapes your seasons. The solar system carries you through the galaxy. The galaxy carries you through the cosmic web. And the atoms within you turn with quantum precision, holding your body together with a fidelity that spans the boundaries between physics and life. The stillness you feel is not the absence of motion. It is harmony within motion. You are carried perfectly by the turns of Earth, by the cycles of stars, by the rotation of galaxies. You are supported by motions older than time as you experience it, older than light, older than the space your body occupies. Everything that spins continues spinning. Everything that turns continues turning. And everything that carries you within that same ancient rhythm, steady and soft. You drift in the arms of motion that began before the first atoms formed, before the first stars shone, before the universe cooled into transparency. These motions are woven into the structure of matter, into the shape of galaxies, into the cycles of your own body. And without ever needing to command your attention, they hold you gently, endlessly in the quiet turning of the cosmos.